So let's talk about symmetry. So today, the first thing we're going to discuss is a line of symmetry. And that is a figure. A figure has a line of symmetry if the figure can be mapped onto itself by a reflection in a line. So think of like when you look at yourself in the mirror is that line of reflection. Okay. So in this case, oh my, if it'll actually work. If we talked about the line of symmetry for this shape, it would land right here. Where if I took this and just kind of folded it, it would line up perfectly. Okay. Next, we have the degree of rotational symmetry. So before you can apply the formula for the degree of rotational symmetry, you need to determine if the shape has rotational symmetry, and that definition is below. To calculate this, use the 360 degrees and divide it by n, the number of vertices. Here is a hint though, this only works for regular polygons. It will not work for anything else. Anything else, you might have to kind of eyeball it, okay? Now, the definition for rotational symmetry is a figure has rotational symmetry if the figure can be mapped onto itself by rotating the figure less than 360 degrees about a center point. So think of a pinwheel. Rotational symmetry actually means like if I took this shape and I rotated it this way, counterclockwise or clockwise, it will land and match up perfectly on that next area, okay, without changing the overall shape. These are still rigid motions, okay? You're just seeing if they're symmetric or not. Questions so far? Okay, so let's take a look at the, it says determine if the figures have a line and / or rotational symmetry. Check all that apply. If the shape has rotational symmetry, find the degree. Now we're going to find the lines too, because I want you guys to know that there's more than one line of reflectional symmetry as well sometimes in shapes. Now we're going to assume that this is a regular polygon. What kind of polygon is this? Who knows? It's a hexagon. So this hexagon is definitely going to have a line of symmetry. And if I drew this, there's one. Here's another, but we could also go down the middles. So if we look, we have a total of 1, 2, 3, 4, 5, 6, about 6 lines of symmetry. You right, Kiro? Where did I get this? I just drew it. Because remember, the line of symmetry is if I took this and I folded it, this point would land right here and everything else would line up too, right? So that happens in 6 different areas for this shape. And because this is a regular shape, this will also have rotational symmetry. So we are going to take 360 divided by the number of vertices, which is 6. So what is my rotational degree of symmetry going to be? 60 degrees. Questions on that? All right, let's take a look at this next one. This definitely has line of symmetry, and we're going to assume again that this is regular, which means equal sides, equal angles. So if I draw a line of symmetry here, here, and here, we know that there are a total of 3. But because this is a regular polygon, we're also going to have rotational symmetry, which means we're going to take 360 divided by 3 total vertices, leaving us with a total of 120 degrees for the rotational symmetry. I keep hearing what? Who has a question? No? I heard somebody said it, and I just want to make sure. You said Miss Smith? Oh. All right, let's take a look at this guy. So for number 3, this is not going to have lines of symmetry. So we're not going to check that, but this will have rotational symmetry. And because this is not a regular shape, what you need to start to visualize is pick a point. When is this going to map back onto itself? It won't map back on there, but it will map back onto here. which means this will be a total of 180 degrees. You cannot use the formula here. You have to visualize it. What's up?
Wait, I'm confused.
On what?
How did you get 180?
Because if I did a 90-degree rotation, I'm trying to get this back onto itself, right? Yeah. If I did a 90-degree rotation, I would end up here. Would that map onto that? No, but it would map back onto here. So that's why it's 180. Does that make sense?
Yeah.
Good question. Any other questions? All sides are equal. All angles are equal. That's known as regular. Yeah, it has to be regular. Okay. Good question. Any other questions? All right, let's take a look at number 4. So this definitely does not have any lines of symmetry. Now the rotational symmetry, again, if I picked a point and I rotated it here, that's not going to map, right? If I rotated it to here, that's not going to map. It's going to rotate back to here, which means that's a whole 360-degree rotation. So this does not have rotational symmetry. So this is just none. Why don't you guys try 5 through 8 on your own? For number 5, that's a pentagram, which is very similar to a pentagon. So that will have rotational symmetry. The question is, what will the degree be?
What's 360 divided by 5? You can do it.
Yeah.
Yeah. This one. 360 divided by 5. This one's rotational. This is rotational by 180. Yeah, I think. Yeah, you're actually right. Is it not?
No, it is.
Okay. 360 divided by 5 is 72. Yeah, 72 degrees. And then number 6 is 180. It's rotational.
Sorry.
7 is. Yeah, it is. 7 is the line. Yeah.
What the heck?
Is there just one line? I got maybe.
Wait, so
For number 6, would there actually be the line of symmetry? Yeah. Would this not be the line of symmetry?
This, I think this is none again.
It goes from here, right? And then you rotate 180, and then this
Wait,
ends
Mrs.
up
Smith?
where
Yeah.
this
So if
is, and
there's
that.
no, if it's like not rotational, then there's just no degree.
Yeah. I mean, technically it's 360, but we don't worry about that because it has to be less than 360 at rotational symmetry.
Just one.
A 97.
It's the same on both sides.
Nailed on that.
Bro, who is
No, I get
Show of hands who's still working on these. All right, let's take a look at the key for this part. Wait, who's still working on it? Okay, just checking. Symmetry. I'll alert the times. Thank you. Okay. So here is what I have for that. Okay. So this first one definitely has lines of symmetry. In fact, it has 1, 2, 3, 4, 5 total. And it has rotational symmetry. Now, if we looked at this as if it was a pentagon, which you technically can do, okay, you find the rotational symmetry just a little bit easier. Like if I connected here, 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 and here, we will have a regular pentagon. Okay. So in this case, it would be 72 degrees. Now this one, it's not going to have a line of symmetry, but it will have rotational symmetry. If you did 90 degrees, it would end up like kind of over here. Like if we looked at this point, it would end up over here, but then you have to come all the way down. So this is 180 total. 7, there's no rotational symmetry outside of 360 degrees, and it has to be less than that. But there is a line of symmetry just straight down the middle. So this has a total of 1. And this is nothing. There's nothing that's going to map. Rotational is 360. Okay. Questions on that? All right, let's take a look at these next few shapes together. So now we're getting into like some different things like pinwheels and different shapes. So if we look at this first one, this does not have any lines of symmetry. Doesn't matter where I put these, nothing's going to map onto itself, okay? But it does have rotational symmetry. And again, this is one that you kind of have to visualize probably a little bit. What do you think it's going to be? 90 degrees, yeah. Now this next one definitely has rotational symmetry. Who knows what it's going to be? 180, very good. How about the lines of symmetry? Yeah, it's definitely going to have 2. It's going to have 1 here, 1 here. Now we have R. Line of symmetry? None. Rotational? None. So this is just none. Let's take a look at this. This looks kind of like a kite. Is it going to have rotational? No. Is it going to have a line? Yes, it will. And where's it going to land? Yep, smack dab in that middle. Very good.
Oh wait, you on?
Yeah, we can't do any more than that. All right, let's take a look at, I'm going to clear the screen. Let's take a look at 13. Now 13, what do you guys think here? It's kind of a funky shape.
Oh no, you can do line.
Where's the line going to go?
Right in the middle. Oh no, what? Oh, you can. I told you.
Yeah, if you guys look right here, there's definitely one right there. And then right here. And then right here. And if you guys look at this is very similar to what kind of shape? A triangle. Okay. So it definitely has lines of symmetry. It's going to have rotational symmetry. What's the rotational symmetry going to be? Helpful. Thank you.
Somewhere between 90 or 180 or 360.
120.
Oh no! Oh, because triangle equals you on track. Oh no, I am stupid because I was like 365 3 is 90. You know, it's not.
All right, let's take a look at 14. What are we thinking here?
No, it's rotational though.
All right, what's the rotation?
180.
180. Very good. Anything else? No, that's it. I definitely got over these with you, the 15 and 60 with you guys, because these are not bad, just a little weird, right?
Oh my god, there's no bottom line.
So if you take a look at 15, this is, think of it as like a 4-leaf clover, I guess, right? Is this going to have rotational symmetry? What's it going to be? 90 degrees. Very good. Because if you go from here to here, 90-degree rotation, we're good. All right. Is it going to have reflection or line? I'm sorry. Yeah, it is. It's going to have lines of symmetry. Now, if you got to go through here, but you also have these angles. So it looks like it has a total of 1, 2, 3, 4. How about 16? Is it gonna have reflectional or lines of symmetry? No, it's not gonna have that. It does have rotational. What's it gonna be? 180. Very good. 17 through 20. I want you guys to try this one on your own.
So this one has no line, nor rotation. Why is it a clearance? There's one line right there.
Does 18 have a rotation too?
No.
17 is not.
Ooh, number 9 is kind of hard.
So
Eight
it's
recycle.
120, bro. It's 120. Rotation.
Are you sure? Oh yeah, it is.
There's no lines. A snowflake?
Okay, well, I don't know if I got this right. I know you only.
There's gonna be a lot of lines.
Four.
I got 4. Wait, no,
Four?
there's
There's
way more.
six.
I got 4.
There's six.
There's 6. There's 6.
Oh, excuse me.
I only got 4.
Because you're missing something.
You're missing the one in between, bro. You're missing the one in between.
Yeah, look in
Oh
between.
wait, I found one.
Look in between the lines.
Yeah, I got it.
Not that you found the one.
I found the other 2 by. No.
Show of hands who's still working on 17 through 20.
Pretty light work.
Yeah, it is pretty light work today, not gonna lie.
Work.
And here you go. So 17 is none. It's 360. There's nothing that's going to reflect. 18, you're going to have 1, but no rotational. 19, you're going to have rotational of 120, but you're not going to have anything else. 20, the snowflake, is definitely rotational, 60 degrees. If you look at it, it's kind of like a hexagon. And the line of symmetries will go in between like the 2 branches, but then down the middle of the branches as well. Questions on this? Okay. So you guys have this whopping 1 page of homework. So you can get this done before you leave. And then remember, I want you to take out your transformations, your translations, reflections, and rotations homework and check those keys. Make sure we are good before Monday. Okay, I don't want to add anything else if we don't have those skills. Does that make sense? Yes.
How many lines of symmetry does a circle have?
Infinite. You have to remember the thing about these polygons is that all of them are based off of a circle. I can draw a circle around all of this, and that's the goal. Okay. Anything else? All right, guys, have at it. Those who watch at home, have a great day.